Hello everyone, my name is Misha Nambiar and I welcome you all to Aptitude360.online. Today we are starting with our Introduction to Trigonometry series where this very first video is about trigonometric ratios. But before we start trigonometric ratios, let us try and understand what actually is trigonometry. As the word suggests, trigonometry is all about triangles. To be very specific, trigonometry is that branch of mathematics which studies the relationships between the sides and angles of a triangle. Do you know, friends, the word trigonometry has come from three Greek words, that is tri, which means three, gon, which means sides, metron, which means measure. Now, in this introduction to trigonometry series, we are going to particularly talk about right angle triangles, the triangles which have 90-degree angle in it. The other two angles in this right angle triangle are known as acute angles. What are acute angles? Acute angles are the angles which measure between 0 to 90 degree. Now, either you can choose this acute angle or this acute angle for your trigonometric ratios. Whichever acute angle you choose becomes your angle of reference, which is oftenly represented with a Greek term called theta. However, it is not mandatory to use this term. It can take any variable, be it alpha, beta, gamma, ABC, PQR, anything, right? But what it is called? It is called angle of reference. Why am I reiterating on this? Because this you will be using in your trigonometric ratios questions. So you need to understand the angle of reference is your acute angle, two angles other than 90-degree angle. Now let us understand what are trigonometric ratios. The ratios of the sides of a right angle triangle with respect to its acute angles are known as trigonometric ratios. Now these ratios are also called T ratios. If you have watched my earlier video, you would know what are these three sides of the right angle triangle called. These three sides are called hypotenuse, perpendicular and base. Let me represent them with alphabets H, P, B. Identifying hypotenuse is very easy. It is the side opposite to your 90-degree angle. However, your perpendicular and base depends upon the angle of reference. The side opposite to your angle of reference is known as perpendicular. The side opposite to your angle of reference is known as your perpendicular. And the side opposite to your 90-degree is known as hypotenuse. Whichever side is left is your base, or you can also say the side adjacent to the angle of reference. The side which is adjacent to angle of reference. If you have watched my earlier video, you would know that there is a relationship that exists between these three sides. That is called Pythagoras theorem. Pythagoras theorem states that the square of the hypotenuse is equal to the sum of the squares of the other two sides. What are the other two sides? Perpendicular and base. So that means if you know any two sides of the right angle triangle, then you will be able to find the third side, because there is a clear relationship between the three sides of a right angle triangle. If you know the perpendicular and base, then you can find the hypotenuse. If you know the perpendicular and hypotenuse, then you can find the base. If you know the hypotenuse and base, then you can find the perpendicular, right? So in any trigonometric ratio questions, the first step will be to identify your angle of reference. Second step will be to identify all the three sides of the right angle triangle, right? So let us do some question on identifying hypotenuse, perpendicular and base so that we are clear with the basic concepts. Take 2 seconds to read the question, friends. It says, indicate the perpendicular, the hypotenuse and the base in the correct order with respect to the angle marked as. As I've already told you, the angle opposite to the angle of reference is your perpendicular. Now, what is your angle of reference? It has already given you, it is x. So, wherever angle x is given to you, it is nothing but your angle of reference. Now, the side opposite to your 90 degree is your hypotenuse. The side opposite to your angle of reference is perpendicular. The leftover side is your base or the adjacent side with your angle of reference. Now, I hope you are able to understand how to identify a hypotenuse, perpendicular and base. Quickly take 2 seconds and solve these 2 questions as well. I hope you are done. Opposite 90 degree hypotenuse, opposite angle of reference perpendicular, the leftover side is base. Opposite 90 degree hypotenuse, opposite angle of reference perpendicular, leftover side is base. Now, what all ratios can be formed using these 3 sides? There are a total of 6 ratios that can be formed using these 3 sides. Let us understand those ratios. It can be either P upon H, B upon H, it can be P upon B, it can be inverse of the first one, which is H upon P, H upon B, B upon P. That is it. Only 6 ratios can be formed out of the 3 sides of a right angle triangle. Now, all these 6 ratios are with respect to some acute angle. Let it be angle A, and I am marking it as angle theta. Now, all the 6 ratios have certain names to it, trigonometric names they are called, which is called sine of angle theta or sine theta. Now, friends, sine theta is just an abbreviation of sine of angle theta and not the product of sine and theta, right? Always remember that it's sine of theta is the abbreviation of sine of angle theta and not the product of sine and theta. It applies to all the other ratios which I'm going to write now. All the other ratios have similar names like these. For example, the second one is called your cosine of angle theta or cos theta. Third one is called your tangent of angle theta or tan theta. Fourth one is known as your cosecant, which is your inverse reciprocal of sine, because the ratio is opposite of the sine's ratio. So this is cosecant of angle theta or cosec theta. Opposite of reciprocal of cosine is your sec or secant of angle theta. In short, it is called sec theta. The inverse relationship of tangent is cotangent of angle theta or cot theta. Understandable? Yeah. Now, all these 6 ratios have some properties to them. You need to remember them so that you do not face any problems. For example, all these ratios are real numbers and they do not have any unit, because the unit in the numerator and the unit in the denominator is same and they get cancelled. So, all these 6 ratios do not have any unit and they are all real numbers. And as we all know that the hypotenuse is the biggest side of all the 3 sides of a right angle triangle, what does that mean? That wherever hypotenuse is in the denominator, the ratio cannot be more than 1, because your denominator is larger than your numerator. So, how can it be greater than 1? So, definitely these 2 ratios will be less than or equal to 1. Right? We do not know anything about the perpendicular and base. They can take any values. So, the values can range from minus infinity to infinity, where infinity can be represented for not defined. We cannot define what can be the value of P upon B? So I can say it can take the value of minus infinity to infinity. Similarly, if your hypotenuse is on the numerator side, then that means the ratio will be greater than or equal to 1. Why? Because your numerator now is bigger than your denominator. So that means your ratio will be more than 1. So if anybody asks me, can 12 by 5 be a value for sine theta? I will say no, it cannot be a value for sine theta. Why? Because the numerator is bigger than the denominator. However, I know that in sine theta, the denominator has to be the bigger number, right? And similarly, if tan value is from minus infinity to infinity, the cot's value will also be from minus infinity to infinity, because the two sides are same, base and perpendicular, and we do not know what all values they can take. Now, one more point to remember, as I've already told you that if you know any two sides, then you can find the third side. What does that mean? If you know any one ratio out of these 6 ratios, you will be able to find all the 6 ratios, because one ratio has 2 sides to it. If I know one ratio, that means I would know perpendicular also, I would know hypotenuse also, then I will be able to find base also. Once I know perpendicular, hypotenuse and base, then I will be able to solve all the 6 ratios, right? So let us do a question. Okay friends, before we go to that, you might ask me, Misha, how do I remember all these complicated ratios, right? So there is a very famous relationship to remember, how to remember these ratios, which is known as Pandit Badri Prasad Har Har Bole. So what you have to do is you have to take the first alphabet of these words and write it down. Pandit Badri Prasad Har Har Bole. So with this we have got 3 ratios. By remembering these 6 words, you have got your 3 ratios. But you need to remember the sequence of the ratio names, which is sine theta, cos theta, tan theta, right? Now, if you make it reciprocal of this, Har Har Bole Pandit Badri Prasad, it will be Har Har Bole Pandit Badri Prasad. Now it is the reciprocal of sine, cos, tan, which is cosec theta, sec theta, cot theta. Right? You will be able to remember all the 6 ratios. There is another way, which is in English, which is called some people have curly brown hair through proper brushes. Where some represents your sine, some people have cos, curly, brown hair, base upon hypotenuse, through is for tan, proper P brushes. In this, what you need to remember is the reciprocal relationships of these 3 ratios. For example, I need to remember the reciprocal of sine is cosec theta. When I know that, I can reciprocate the ratio also. Then cos theta, reciprocal is sec theta, h upon b. Tan reciprocal is cot theta, base upon perpendicular. Whichever mnemonics is easy for you, try to remember the ratios through that. I have learned this mnemonic throughout my life, so I will be using these mnemonic in my questions to solve, right? So let us do a question. And so the question says, from the following figure, find sine A, tan A, cos C, cosec C. So my first step is to identify the angle of reference. So in my question, I have both the angles, angle A as well as angle C as angle of reference. So what I will do is, I will write angle A, angle C. According to angle A, I will identify my HPB. according to angle C, I will identify my HPB. And according to angle A, my H will remain the same in both the cases, which is the side opposite to your 90 degree, which is AC, and which is 13. When I keep angle A as my angle of reference, which is the side opposite to angle A, it is your BC. That means your perpendicular is BC. And the other leftover side is AB. And when I keep angle C as my angle of reference, the side opposite to angle C is my perpendicular, which is AB. And the base is the leftover, which is BC. Right? Now, I do not know the third side. So, by applying Pythagoras theorem, you will be able to identify the third side, which will come out as 12. You can do the Pythagoras theorem equation on your own and solve it, and you will be able to identify that it is 12. If you are not able to do that, leave it in the comment section so that I can clarify in the next video. So what is your perpendicular? Here it is 12 and B is 5, and here perpendicular is your 5, BC is 12. So I have got all the sides now. Now what is my third step? I will write down the ratios, remembering the mnemonics. Some people have, through proper brushes, curly brown hair. Cosec is opposite of sine, which is hypotenuse upon P. Now sine A. So angle A as my reference, what is my perpendicular? It is 12. I'm just filling in the values now. What is my H? It is 13. Keeping again angle A as my angle of reference, what is my P? It is 12. What is my base? It is 5. Keeping angle C as my angle of reference, what is my base? It is 12. What is the hypotenuse? It is 13. Keeping angle C as my angle of reference, what is my hypotenuse? It is 13. What is my P? It is 5. And therefore, I am able to solve all the ratios. So what I did was, first I identified the angle of reference. According to that angle of reference, I identified my HPB, which is hypotenuse, perpendicular and base. Then I found all the three values of the right angle triangle, and then I wrote down the ratios using the mnemonics memory method, and then I filled the values. That is it. If you are able to remember these steps, you would be able to solve the questions. Let us do another question on this. If tan A is equal to 4 upon 3, find the other trigonometric ratios. So through the mnemonics, we know through proper brushes, that is tan A is equal to perpendicular upon base, which is 4 upon 3. Now one thing we know for sure is that angle A is not your right angle triangle, right? It is your acute angle because it is your angle of reference. So you have to make a right angle triangle at, so you have to make a right angle triangle at B, and then A and C can be anywhere. Now angle A is your angle of reference and your hypotenuse is this, perpendicular is this, because this is the side opposite to your angle of reference, and this is your base. Using Pythagoras theorem, you would be able to identify the third side, which will come out to be 5. 3 square plus 4 square gives you 9 plus 16, which is 25. The square root of 25 is 5. Now you know all the three sides, which is H is equal to 5, P is equal to 4, B is equal to 3. Using these 3 sides, you have to write down all the 6 ratios. Take 10 seconds and write down all the 6 ratios, keeping angle A as your reference. Right? How would you write that? Sin theta, some people have curly brown hair through proper brushes. Now sine ka opposite is cosec, cos ka opposite is sec, tan ka opposite is cot, and then you just have to fill in the values. What is the value of P? It is 4, hypotenuse is 5, base is 3, hypotenuse is 5, 4 upon 3, hypotenuse is 5 upon 4, 5 upon 3, 3 upon 4. All the 6 ratios we have got. Easy, friends. Again, I'm saying you just need to identify the angle of reference. Then you need to find out all the 3 sides of the right angle triangle. Then you have to write down the ratios, fill in the values, and you're done. Let us do another question. This question came in your CBSE 2016 exam. Here you have got only one side and the angle of reference is your angle R. That means this is your P and this is your B. Now I do not know 2 sides of this right angle triangle. So what am I going to do is I am going to apply Pythagoras theorem to see if I can find something, because I have one relationship between 2 sides which says PR minus PQ is equal to 1. So let me see if I can use this equation to find the 2 sides of the missing 2 sides of the right angle triangle. So what does Pythagoras theorem tell me? H square is equal to P square plus B square. Now what is your hypotenuse? It is nothing but your PR square. Perpendicular is your PQ ka square plus base is this was my hypotenuse, my bad. This is my base, correct? The side adjacent to your angle of reference. So what is your base? Your base is have a value of 3. Now if I take this unknown variables to one side, what I would get is 3 ka square is 9. Now we have studied in our algebraic identities that a square minus b square is the product of a plus b into a minus b. So if I apply this algebraic identity here, what will I get? I will get PR plus PQ multiplied by PR minus PQ is equal to 9. What is your PR minus PQ ka value? It is already given in the question, which is 1 centimeter. So my PR plus PQ into 1 is equal to 9. Therefore, my PR plus PQ is equal to 9 divided by 1. This 1 will go down and it will be 9. Now adding these 2 equations, one of the variables will get cancelled because one of them is positive, one of them is negative. So what will be left? We will be left with PR. So what can be, if I add these 2 equations, what will I get? PR plus PQ is equal to 9. PR minus PQ is equal to 1. Now these 2 get cancelled. I am left with 2 PR is equal to 10. The value of PR is 5. Now I've got two sides, PR is 5, I've got this 3, then applying Pythagoras theorem, you will be able to identify the third side, which will be 4. It's a famous Pythagorean triplet, that is why I'm able to apply it again and again. It's 3, 4, 5. Wherever you can see this relationship, you can immediately know that the third side will be 3, 4, 5. Now you have to find the values of sin r. Some people have curly brown hair through proper brushes. What is your P? P is 4, hypotenuse is 5. I'm just filling in the values now because I've already identified the 3 sides. Base is your 3, hypotenuse is 5, perpendicular is 4, base is 3. And I've got my answer. Easy. I'm again telling you that if you remember the steps how to do the trigonometric ratio questions, you will be able to do them very easily. So always remember the questions. This we have already studied. Again, reciprocal relationships. Cosec and sine have reciprocal relationships. That means sine theta into cos theta, cosec and sine theta have reciprocal relationships. So that means if I multiply sine theta into cos theta, you will get a 1. Cos theta and sec theta are reciprocal of each other. So that means when you multiply cos theta into sec theta, you get 1. Tan theta and cot theta are reciprocal of each other. So when you multiply tan theta with cot theta, you get 1. Now there are two quotient relations that you might have to remember, which is tan theta is equal to sine theta upon cos theta. Why is that coming? What is tan theta? It is through proper brushes, right? This is the ratio. Sin theta ka ratio, what is it called? Some people have cos theta curly brown hair. H gets cancelled. What is left is P upon B. Left hand side is equal to right hand side. That means these tan theta is equal to sin theta upon cos theta is true. It holds true. Cot theta upon cos theta, again it is base upon perpendicular. Cos is curly brown hair. Sin is some people have. Hypotenuse gets cancelled and what is left is B upon P. So these two have the quotient relations and there are some questions that are based on these relationships. Let us try and do those questions. So this question says, if m cot A is equal to n, find the value of m sin A minus n cos A upon n cos A plus m sin A. Looks complicated, but let us try and understand and decode what is question referring to. It has given us the values of cot and it is directing us to go to sin and cos. So first, let me try and bring it to tan because it is a reciprocal relation of cot and m. From tan, I will go to sin and cos because I know there is a quotient relationship between tan and sin and cos. Okay, so first step is what is the value of cot A? पहले तो ये निकाल लेते हैं. Cot A है क्या? It is nothing but your n, m goes down because it is the value n upon m. Now if cot A is n upon m, then what will be the value of your tan A? Tan is nothing but the reciprocal of cot A. So that means the value will get reciprocated. M will go in the numerator, n will go in the denominator. Right? Now, how will I make this equation into tan? By dividing it with cos, by dividing this with cos. So let me divide the numerator and denominator with cos. M sin A upon cos A. Just make sure the angle of reference should remain same, it should not change. N cos A upon cos A. If you are dividing this with cos A, you have to divide everything with cos A only. N into cos A divided by cos A plus m sin A upon cos A. अब इसमें से क्या क्या मिल सकता है हमको देखते हैं. m into tan A, right, minus n, क्योंकि cos कट गया. Here also n, cos gets cancelled and I have got n plus m tan A, right? Sorry, I'm taking a lot of space and that is why I have to rub. Now I know the value of tan A from here, which is m upon n. So what I will do is I will substitute the value of tan A in the value from the equation here, and I will write it as m upon n. N plus m into m upon n. So that makes your m square upon n minus n plus, these are all fractions, friends. I hope you all know how to solve the fractions, upon n square plus m square upon n. This n gets cancelled and what you get is m square minus n square upon m square plus n square. This is your answer. So they asked you to find the value of this. The value of this is this. Simple answer. I hope you understood this concept. Let us move to the next question, which came in your CBSE 2019 exam. What they are asking you to do is, they are asking you to prove tan theta upon 1 minus tan theta minus cot theta upon 1 minus cot theta is equal to cos theta plus sin theta divided by cos theta minus sin theta. So let us first take the left hand side and try to reach on to the right hand side. So my left hand side has what? Tan and cot, and I have to convert them into sin and cos. So I know the quotient relations of tan and cot. I will directly use them. Tan theta means my sin theta upon cos theta 1 minus sin theta upon cos theta minus cot is your cos theta upon sin theta divided by 1 minus cos theta upon sin theta. Right? Now just you have to solve the fractions. Sin theta upon cos theta, this becomes your cos theta minus sin theta upon cos theta. Cos theta in the denominators gets cancelled, minus cos theta upon sin theta divided by this sin theta goes in the numerator. When I solve this fraction and I get sin theta in the denominator and they get cancelled. So can you see some similarity in these two? Yes, only the signs are interchanged. Now what do I need in the denominator? I need cos theta minus sin theta. So what I will do is, I will take out the minus sign from here and sin theta upon cos theta minus sin theta. If I take out the minus sign from here, minus into minus gets plus, and this is what is left is cos theta upon cos theta will become positive and sin theta will become negative. So now I have same denominators, so I can club them and write cos theta minus sin theta in numerator. Both the numerator gets added because denominators are same. So I've got this value which is same as your right hand side. So left hand side, I have proved it equal to my right hand side and hence proved, right? Now, if you have understood the concept well, then you will be able to solve these questions correctly. Please take 2 to 3 seconds and pause the video and solve these questions. I hope you should be able to solve them. I hope you liked today's video. In the next video, we will learn about how to calculate trigonometric ratios for some specific angles. Till then, take care and bye-bye. See you in the next video.